Magnetic fields can move through most non-magnetic materials like paper, cardboard, plastic, glass, fabric, as long as the material is not too thick for the strength of the magnet. Magnetic fields weaken over distance, which is why the force might go through a thin piece of balsa wood, but it won't go through a thick wooden shelf. Did you notice that when we were playing with the magnets and trying to make the paper clips move through different materials, sometimes the paper clip moved easily, and sometimes it was a little bit rough or jerky and it was harder to attract the paper clip. This is because of friction. Yes, I know that's not a paper clip, that's a bobby pin, but you know, same. Squeaky! So the kids just got home, so it might get a little bit noisy. This is Theo. Say hello, Theo.
Hello, Theo.
No, you say hello, everybody.
Hello, everybody.
All right, and Hazel's around somewhere. You might hear her too. But we're going to push on with this video. Okay, so when an object is moving across a surface, okay, like my paper clip is moving, not my paper clip, my bobby pin is moving across the surface, the contact between the object and the surface is called friction. Okay, friction is the force that sticks things together and makes them slow down. Okay? So friction occurs between all types of materials, whether they are solids, liquids, or gases. Oh.
How about dots?
What?
How about dots?
What?
How about dots?
How about what?
How about dots?
How about those?
How about dots?
What?
How about the dots?
How about the Dutch?
How about the dots?
How about the Dutch?
How about the dots?
You want me to turn it off?
Yeah.
Why?
Bobby. About the other Bobby is that one and me.
Okay, let's try this again, and I'm going to go quickly while the children are playing outside. Okay, so the friction occurs between all types of materials, whether they are liquids, solids, or gases, and the friction force goes against the direction of the movement. Okay, it's caused by the interaction between the two surfaces, causing them to stick together and make the movement between them slower. So the friction force slows the movement. Okay, scientists and engineers try to find ways to decrease or increase the friction in a particular situation. Okay, this is because sometimes the friction can be useful and sometimes it can become a problem. Okay, so an everyday use for friction in a good way is the friction between the brake pads on your bike and the tyre. Okay, for example, the brakes on the bicycle rub against the tyre and it slows it down. So the brakes get pushed and it slows them down. The brake material is chosen to create high friction and when pushed against the rubber of the tyres. In this situation, you want there to be a lot of friction because if there isn't, your brakes won't work very well. Okay, if it's raining, the brakes don't work as well because water lubricates the wheel and lubrication decreases friction. Okay, so perhaps maybe in the engine of a car, you would use lubrication to keep the moving parts of the engine from getting too hot because friction creates heat, and that would be a bad example of friction, where friction will be a problem. So that's why we lubricate our engines to keep them smoother. We decrease the friction and therefore we decrease the heat in the engine and the wear and tear on the engine parts. Okay, so friction can be good or it can be a problem. Okay, it's good if it helps us to slow down our bikes before we crash into a tree. Bad if there's too much friction in the engine and it creates wear and tear or too much heat and maybe the car will blow up. Something like that. Okay? A friction force opposes the direction of movement, so that means it goes against it or in the opposite direction. So when you're doing a force arrow diagram, the friction force arrow is drawn in the direction going against the motion of the object. So here is our picture of a guy. He's riding his bike and his motion, he's going in this direction. Whoop, this way. This is his motion. Okay, let's make that red. His motion is going in this direction. Okay, he's pushing with his feet on the pedals, and that is propelling him forward. So his thrust is going forward in that direction. Now, here is the surface of the road. Where do you think the friction might be occurring? That's right. The friction is occurring between his tyres on the road, front and back. And the friction is drawn this way. So the friction occurs between the surface of the road and the tyres of his bike. So Hazel won't leave me alone, so we're going to finish off this video together. Say bye-bye, everybody.
Bye, everybody.
Okay, now remember, summarise the main points of the video, and don't forget to ask a question if you need to ask a question. I hope you like this one. It was a little bit crazy with the kids around, but hopefully the next one will be nice and quiet. Say bye.
Bye.
Bye. Bye, kids.
Bye, kids.